Hello guys and girls, and welcome back to my video where today I'm going to be explaining to you guys written homework 3 for Dr. Schweller's assignment. So before we get into, solving the problems themselves, let's see what we're asked to do. So the first problem is find a medium. So we're having two sorted arrays, one having n items, one having m. We're supposed to solve this algorithm in log of n. And mostly just it for that one. A heap that can get either the largest or smallest item quickly. So we're going to have three functions in the data structure: an insert, extract min, and extract match, which are going to be running in log of n, big O log of n. A heap for getting the medium quickly. So it's going to be mostly just derivatives of the first and second problem. It's because we're using heaps and we're extracting the medium. So let's get into this problems. So the first problem, it's fairly simple to understand. So what algorithm runs in log of n to find a medium point? Well, an algorithm that runs in log of n is a binary search. But this isn't a normal binary search. It's going to be a little bit modified. Well, by a little bit, it's going to be a lot. Oh, sorry about that. So, what are we going to do first is get the total size that we're working with. So, let's construct a binary search right now. So what would we mostly be using? Well, we have A and B with their corresponding size, where n is always greater than or equal to b. So this algorithm won't be running in log n squared. Also, I put that as b, even though it's supposed to be m. But you guys get the gist. So it won't be running in this. It'll be running because that will be log of n squared using this type of algorithm. Now, what we're going to be doing is we're going to be using a as our endpoint, the size of a as our endpoint. So, first things first, let's get the size. When you're programming here, we have the size of a and b, so we can just get it. But our starting point on this binary search is going to be from 0 to a, or a.size. And, well, we're going to be having two types of mids. We're going to have our upper mid and our midpoint. So, you guys know how mid works. So it's from the start to the plus the n divided by 2. Now, let me say this. Let me draw a whole line here. So this right here would be our mid of this algorithm, or like let's say a, this data structure. I mean this let's say this a, and our upper mid would be the combination of the size of a plus b plus 1 divided by 2 minus our midpoint. So the reason for that is we want to get, well, an upper mid. For example, let's say, I don't know, right here. This could be an upper mid. So the equation for an upper mid would be a plus b plus 1 divided by 2 minus our current mid. So that would be mostly it. So we're going to have to we're gonna be doing this. Okay, so let me erase this. So let me see if I can explain this as good as possible, because it's a little bit confusing, my explanations here, and there's not much here to do. So we're gonna be doing sort of we're gonna be checking left and right in our whole what is it called, our two arrays. So our left side, we're gonna be mostly checking that if let me see, how can I explain this? Let me see how much I can explain this to you guys without giving out much of an answer. So we're gonna be splitting up our A and B. Let me see what this is. Where our upper, I've memorized what an upper mid is now, because I just forgot. So our midpoint is just going to be this point for A. And this to here is the left side. Well, let's say my upper mid, which is where B is played around to, is this point from this point. So it's this one too. From here to here. And yes, I'll post this. Yeah. No problem. It is all posted. Wait, I lost my notes. Where's my notes? Oh, there it are. So, what are we checking here? So, what we're checking is... Oh, okay, and then let me give out the explanation for the right side of mid. So, this left... Alright, left 2, and from mid to over here, that's your right side. Upper mid to over here, that's your right side. So, what are we doing here? Well, we're mostly just checking some things here. So first check, what I will check is my midpoints. So, let me think this one through. Because there's some conditions, but what we want to do is we're going to be iterating through this. All right, let me think how to... So, what would you do here? Because we checked mid, and what happened if mid is equal to 0? Well, we just... If it's false, we reassign it to mid minus 1. If it's true, then we assign it to some minimum value. And the same thing goes for upper mid. If upper mid is 0, so check mid at this, check this mid, and it's 0. Assign it to some minimum value, anything, I don't know, negative 100 or something like that. And then if it's false, we assign it to the next point of the mid, so minus 1. Mid minus 1 on A minus 1. And similar process on B, but at this time you're using upper mid. But rather than, upper mid minus 1. So there's just some conditions you need to check. Now for the right side, you're going to check if it's the size of A. So if this is the size of A, is it really your mid? Kind of. If if it is the size of A, set it to some maximum point. If it's not, leave it as it is. Don't worry about it. If the right side on this one, it's similar process. Just if it's like size of B, then set it to some max point of something. If it's not, just leave it as is. Leave it if not. So that's mostly just some conditions that I made. I know there's some better ways to explain this, so I'm not really... don't really know how to... This is one of the ones I probably got confused on while trying to learn about it. Now that we have our locations, our inputs that we're working on, if our left sides of A and B, the right sides of A and B, what we need to do is we need to compare. So this is just, when I mean left, it's just 1 point, like A mid -1, left 2, A mid, B upper mid -1. It's just one element from the whole array, and we're going to be comparing them. So we're going to compare our left with our right. So how this will look in our array is so our left, because this is our A and B. So okay, so let's say this is my midpoint, because for now, and then my upper B is going to be some sort of B upper. Where can I do this? If upper mid is equal to B size, that means else. So let's say, what would upper B be? So combination of both plus 1. I'm just going to do it here. I'm not doing math right now. And then we're doing the right side, which is this one. The left side would be a little bit further down, but this is going to be our upper mid, our right side. So we're going to be comparing these two and checking if this is less than my right side of B. And you also need to do the same condition, but for like the opposite condition, because this is your left of A, and this is your right of B. And then let's say this one right here, that one's your right of A, and this one right here is going to be your right, no, over here, it's over here, left of B, right here. So you have to check if the left portion on both sides is less than or equal to the right portion. This is one of the conditions that needs to be met. And if you do, check both sides. So check the size. There's an error in that code. Yeah, this is not going to be a good explanation. Let me look at my other... documents. So, let's see. From here, we can determine the two arrays can be divided properly to find a medium. Okay. However, in the case that the number of items is odd, the medium will be found in one of the left halves. So, those are just, there's some conditions about like odd and even depending on what the total amount is. And I'm trying to see how to solve this one, because it's
been quite a long time since I've done this, and I know there's a problem that can be solved, and I can't seem to find my notes on it, so I have to ask some other people if they could lend me them. So this is the one problem I don't have my notes for. So let's see here, because he has an if statement of both sides A and B with a notation of 1. But there's some conditions where if that's true, something about the size, it's just the 1 and 1. He returns the max of either left of A or left of B. If that condition is incorrect, then he returns the left of the left of A, left of B, plus the minimum of right of A and right of B. So just get the max points of whatever. So depending on what left A and left B are, you have to check which is the maximum. So let's call it max L, and then we have to add it by min of right. And then you divide these two numbers by 2. Yeah, so this is a little bit confusing. I'm sorry about this explanation. The other ones, I hope I can explain this homework. I didn't do so well on this one. If left, so if the first condition isn't met, check the left of A with the left of B. I mean right of B. And check if left of A is bigger. And if it is, you do n equals mid minus 1. Else, right is bigger, you do start plus mid. It's binary search at this point. But that's mostly how I can explain it. Just, you're going to be splitting up the arrays with its left side and the right side of the elements. And from that point, you're going to be using which one's bigger at this point. How can I get the medium? I hope that makes sense. It's not very clear on how this one works. Well, I program it, but they told me I had an error in my code or something like that. So let's go on to question 2, which I can actually solve it without notes because, well, it's pretty self-explanatory. So this one's fairly simple. You guys learned this in class. So you're going to be using min heaps. So min heaps are just, and well, you're not using min heaps. You're using heaps. One where it contains the lowest numbers. So let's say there's 2, 3, that's a 2, 1, and then there's a min heap. And then this are my max heap. So this is 3, 2, 1. So this is your min heap and max heap. So you're going to be using these two to get the extraction of the largest and the smallest items. So can anyone tell me what the runtime of min heap is? Or a heap in general? Well, it's big O log of n. So it's just fairly simple at this point. You're inserting one element. So let's say I'm inserting the 3. On my min heap, it's going to be 3, and then on my max heap, it's going to be 3, 2. Let's say I input another item, which is 2. So this one rearrange itself. So it's going to be like this and like this. So kind of like this. This is how you're going to be inserting at the same time, and then you're going to be organizing your heaps. One key thing that you have to do is swap indexes, because it's going to be used. We're going to be using like a vector to keep track of these things. This heap. You can use a vector or array, whatever you guys want. But we're going to be keeping track of where our location is at. So what other data structure do you guys think that can keep track of an index and a data? So, you have your two integers. And what type of data structure would you use to keep track of it? Well, that's something that I'm going to let you guys have guessing, because, well, it would still run. You're just inserting these points. Now, that's mostly just the insert. Now for the extract mid. So that's insert and keeping track of your information. Now let's extract min and max. So let's say I have an item of 2 and I wanted to extract it. Well, I'll go into the data structure that I'm working with that has an integer that I'm inputting, which is in this case 2, and its corresponding index. So at this point, if we extract from here, we have to extract from our max or our other heap. So we're gonna extract this. So let's see. So I have the location on both. I have the location of both indexes placed in my location for. So I guess you can do 2 different data structures, where this one's for my min and the other one's for my max. And just keep track of it. You extract it, resort it, or you do what a heap does, and do the same thing to your max heap. So extract it. So put it at the very end. I don't know, like just so the order keeps going. So swap with the very last element, then do a pop. I know it's not correlated, but what I want to say is you're keeping track of the order. You're keeping track of the location in the other heap that you're not working with. Because if you're working with one heap where you're extracting something, you have to do the exact same thing to the other one, because that information's already gone. I hope that makes sense. I'm going on to the third problem. It's just like, how do I explain this? It's just not much to explain. You're going to be using 2 heaps, keeping track of their order. Extract. If you do one extraction, you have to remove it from the other side. Now let's do the third problem. So let me read my answer sheet. Alright, I got it. So for this one, we're going to be using a median heap. And we have our insert and extract min value. So be either an odd number of items in the heap or floor to the middle items. And so if we have an odd number of items, we just put into the heap. If we have an odd number of items in the heap, be a single item when there is an odd number of items, or the floor of the 2 medium items in case even numbers of items. So in order to do this implementation of the median heap, we're going to be using a vector that holds two different heaps, which is our max and min. And let me see here. So, what are we going to do here? Let's see if because I paused, I want to see if that worked. Probably not. But, you're going to be using two min heaps and keep track of the medium. Similar, because you're going to be using the same algorithm you use. Kind of. But, we're going to keep track of the min heap and the max heap, every single item, whenever... okay, let's talk about the insert here. Insert. Two conditions to keep track of is the size of your min heap, and your max heap. And, when the first item is inserted, well, the first item, so we just put it in the medium heap. And we're going to store it into a vector as the current medium of the database. Now, if a new item is inserted and it's less than our current medium, then we insert it into our max heap. And if the new item is inserted and it's greater to our current, we insert it into our min heap. So we're keeping track of this information here. So we're making two different heaps. They're not going to be working similar to question 2, but we're keeping track of the information. So let's say I have my medium heap is 5. So anything greater than this would be, let's say this, my max. So let's say 5, 1. 1, something like this. 5 and 6. My medium heap. Alright. Now let's see here. So that's mostly just it. You're gonna put everything inside a vector. Yeah, this is not a good explanation. I don't like this homework written 3. It's one of the ones I did pretty badly. Well, not really. Just confusing. Because by wasting my time trying to actually create the algorithm. However, in the case of the min heap is more than 1 item greater than the max heap, after insertion, that means the median heap for the data, blah blah blah. This allows 2. Alright. Yeah, not a good explanation on this one. That's pretty bad. Yeah, this one's pretty bad. I don't have questions. I know how to solve for them. I know, but I don't know how to explain it. Because you're using 2 heaps. How I solved for mine, I believe, is using 2 heaps, your min heap and max heap. And you're keeping track of where you're currently using. What I mean is I keep track of it in a vector. What's going to be my next medium? Which one has a greater value? However, in the case of medium, I don't know how this would look. Blah, blah. Yeah, this is a failure. Don't know how to explain this one without students being here. But mostly inserting the most data structures that you're going to be using is a min heap, max heap, and a medium heap to keep track of where you're at. And when you extract it, what we're doing is return the medium, and the new medium is based on whatever min and max will give out. If the vector is odd, the medium will be extracted from the max, and in the case the medium and max heap are even, then we have to do the floor of the two medium values are returned. So basically what that means is that what that mostly just means on the extract is that keep track of min and max. Just not keep track, just say size of min.size, max.size, add them together. Is this odd or even? Well, if it's odd, extract from max. And then reorganize your whole heap. And then if it's even, get the summation of both of them, I believe. Let me see here. It's on the instructions. So in this case, n is even the total number of items. You divide it by 2, and you floor it, and that's what you're going to be returning. Does that mostly just make sense? So it's going to be n is equal to a plus b, and then you're going to be divided by 2, and then you're going to floor it, and that will give it to you. And then reorganize your heaps. You're keeping track of this type of information, so it's mostly just that. So yeah, if you guys need any help, you guys can message me or something. Just if you're stuck, I've helped some students and tried guiding you guys to the correct answer using, what data structures you should be using and how. So alright, thank you for watching. This was a pretty bad video, so no worries about it.